This session will be focusing on some activities that you could use the place value disc for to help kids understand the standards that are written within the grade 3 standards. This is one that I would probably start off with. Okay, I'm going to be putting something on my place value mat. Now, for this purposes of this training, I'm using this place value mat. There is another one that goes a little bit higher up to the millions, and you would probably want to use that one, but for what we're doing right here, it really doesn't matter. Okay, so what number did I just represent? And so what you're hoping is that your students are going to say, well, you represented 10 ones. Okay, what can you tell me about 10 ones? And this is where, from the work that they've already established in the kinder, first and second grade, the kids should have a relatively deep understanding, I think, of the base 10 system, but I think this is always a good starting point for grade 3. So what I want a kid to know is, well, if you have 10 ones, that's called a bundle of 10. So anytime you have a bundle of 10, that's the same thing as 110. So 10 ones is the same thing as 110, which means I can remove these and I basically traded up. So now we have 110. So is 10 ones and 110 equivalent to each other? Sure they are. Okay, now let's look at this. What number am I representing? So I always tell the kids, wait for it. Wait till I finish it, and I'm going to ask you, because you're going to have them right now. They're probably already counting by tens, or they already show 5. And notice I'm building this just like 10 frames for them to subitize that would be 50 and this would be 50, whereas in our ones it was 5 and 5. And they see that connection again, that each one of the green discs, the yellow disc is 10 times larger than this one. So as we move across our place values, these values, if I moved it here, becomes 10 times larger. And that's why I'm able to remove a group of 10 over here. Okay, so we traded. Now, what number is this? And the kids are probably going to say there are 10 tens. Now, one of the things you want to watch for is a kid who says, well, this was 10 tens and 10 tens, so they may end up saying that's 100 tens. Remember, you're only counting the disc as one. So basically then this is 10 disc in the tens place value, so that's 10 tens. Well, what do you notice about 10 tens? Hopefully, oh, there's a bundle of 10 tens. Well, what's a bundle of 10 tens? Notice the coloring. These were yellow, so it means if I get 10 yellow, I could trade up for 1 orange, because 10 tens is 100. And all of these go away because I just moved it up here. So this is 100. And then I'd ask the question, is 110 tens the same amount? Yes. So you can see the progression. Then you would collect 10 hundreds, and 10 hundreds trades to 1,000. And so then I have my 1,000 disc, and notice the color coding is still the same. So I traded these up to 1,000. And you can keep doing this. And this really, really, I think, deepens their understanding of how we work in a base 10 system. Okay, I'm going to remove the mat now, and I'm just going to go to a piece of paper. Well, of course, kids have to be able to read and write numbers up to the 100,000s. So I would just start off, and I may just write a number on the board. And I would just say, take your place value disc and represent this number. Now, notice that if I had that other mat, I would probably start off with these numbers written on that mat, because maybe right now they're just really trying to think about those place values. They definitely should know their place values to 1,000, and you're just coming in with your new 10,000 and eventually just the 100,000. So what this says is we have 6 ones. So I'm going to build my 6 ones. And it doesn't matter whether the ones show or they don't show. So there's what a 6 looks like. It's a 5 and one more. Now, how many 10s do we have? Well, we don't have any 10s, so I don't put any yellows. We have one 100, so I get to put a orange disc, one 100. Then I have 3 thousands, so I need 3 thousands, which are red. Okay, 3 thousands. And then I have one 10,000, which is the purple. So when we look at this, this is how the child should, or the students in your room represented this number. So this says 1 10,000, 3,000, 100, no 10s, and 6 1s. Now, how do we read this number? We read this number as 13,000. So this is a very interesting concept. Remember that if I wanted to move the purple 10,000 into here, how many thousands would I get to trade it for? That's right. I would get to trade that for 10. Seven, 8, 9, 10. And by trading that, that really helps the kids see that you have 10, 11, 12, 13. So 13,000 versus 10,000 plus 3 more thousand, that gives you 13,000. So 13,106. Now, you could sit and just do that over and over and over and again, that trading to realize how we read and write numbers in our 3rd grade standards. Okay, let's do this then. It also says that we are to compare numbers. So I'm going to compare these numbers. You have the number 10,131. So I'm going to build. I've got 1 1. I've got 3 10s. I've got 1 100. And then I've got this 10,000. So you can opt to do one of two things. You can say 10,000, or if you wanted to move your purple into the red column, how many of those reds are equivalent to one purple? Well, it was 10 of them. So you could actually do it, like that. But for this, we could just say 10,000. Okay, now let's represent the next number. How many 1s do I have? None. How many 10s do I have? 2. How many hundreds do I have? 2. How many thousands? I don't have any, but I have a 10,000 disc. Okay, if we were going to compare these two numbers, what do you notice? So if you start off with those type questions, the kids may say, well, I noticed there's exactly the same number of purples. Or they may say, well, there's 1 green and no greens down here. There's 3 more here, 1 less here. So then the question comes in, well, then how do you compare numbers? This is where we come into sometimes we use that little trick or rule where we say always go to the highest place value. Well, when the highest place value is 10,000 and they're exactly the same, then those basically just get removed. Okay, now we're only left with 220 or 131. Which one of these numbers is larger if you were even going to put it on a number line? Is it 200 in anything or 100? Hopefully the kid's going to say, well, there's more hundreds here than here. So this number had to be the largest number. And that's correct. 10,200 is larger than 10,100. And these really are irrelevant to the comparison. So this is what some teachers do, that they talk about moving until your digits are different and you're only comparing these digits. But remember, sometimes by holding that entire number, that helps kids who really don't understand, like, okay, is that a trick? Like, how do I know that? Well, 200 was greater than 100, but 220 is a higher number than 131 if we were counting. So that's a way that you actually could compare numbers. And you're actually going to build both of the numbers. You're going to be doing some of that trading out, which is why I started with the trading on the base 10. Make sure that kids understand what happens when you trade here. It's really, one of those discs is a tenth of that one, but when you're trading this way, it's 10 times larger.